Hello and welcome. We're here today to discuss combined heat and power, or CHP. And with me in the studio is Peter Smith. Peter is Head of Research at the Combined Heat and Power Association. A very warm welcome, Peter.
Thanks very much.
So in its simplest form, what is CHP? How long has the technology been around?
Well, CHP is typically the simultaneous generation of heat and electricity in one highly efficient process. CHP has been around for a long time, but it's not really a technology as such. It's more of a process, really, and using heat efficiently can make fuels go a lot further. Your standard input fuels go a lot further.
So are we talking about effectively any power station that recycles its waste heat? That's CHP, is it, in effect?
Not quite. I mean, there has actually been a directive which has laid down what CHP is, the Cogen directive, and that requires certain efficiency standards. So 10% primary energy savings, so saving 10% on the fuel input, and also it requires an overall efficiency of 70% or greater. So if you meet those requirements, then you get to call yourself cogeneration, or CHP as it's known.
Right, OK. So what fuels can CHP use then?
It can run a variety of fuels, really, but the predominant fuel at the moment is natural gas. About 70% of CHP in the UK is fueled on natural gas. But really, it's just really about using those fuels efficiently. And if you've got a high calorific fuel, wood or cabbages or or anything, you can burn it in a boiler, raise steam, put that steam through a turbine, and as long as you're using the heat efficiently out the back end of that process, that's called combined heat and power. But no, some others tend to put heat straight back into the generation process to create more electricity, and that's called combined cycle gas turbine, and that isn't CHP, because often the heat at the end of the process is discarded and not used efficiently.
Let's take a moment to recap on what CHP is and how it works. Combined heat and power is the simultaneous generation of usable heat and power, usually electricity, in a single process. In its simplest form, it employs a gas turbine, an engine or a steam turbine to drive an alternator, and the resulting electricity can be used either wholly or partially on site. The heat produced during power generation is recovered, usually in a heat recovery boiler, and can be used to raise steam for a number of industrial processes, to provide hot water for space heating, or, with the appropriate equipment, cooling. Because CHP systems make extensive use of the heat produced during the electricity generation process, they can achieve overall efficiencies in excess of 70% at the point of use. Now, in contrast, the efficiency of conventional coal-fired and gas-fired power stations, which discard this heat, is typically around 38% and 48% respectively. Efficiency at the point of use is lower still because of the losses that occur during transmission and distribution. In contrast, CHP systems, which vary from micro to megawatt generation capacities, are typically installed on-site, supplying customers with heat and power directly at the point of use. Its supporters claim that an increase in the use of CHP will help the government meet its CO2 reduction targets, reduce the cost of energy supply, and enhance the security of the UK's energy supply.
So, Peter, how much of the UK's power and electricity needs are currently met by CHP, and to what extent is this going to increase, do you think?
Well, at the moment, it's about 7% of total electricity generation in the UK, which, to get techie for a minute, is about 5.5 gigawatts of electricity. So it's quite a bit already. The government has predicted that there's a cost-effective potential to increase this by about another 1.5 gigawatts by 2010, so quite a close time frame. And there's a further potential beyond that for about 4.5 gigawatts of CHP, again, economic potential. other studies have highlighted, other independent studies have highlighted that the technical potential might be a lot larger than that.
OK, so take us through the categories then of CHP power.
Well, let's start at the bottom up. People, once micro CHP products become commercially available, and I'm pretty sure soon they will be, you can replace your domestic boiler in your home with a CHP unit. And we call that micro CHP. And that would typically be up to, say, 5 kilowatts electrical output. Above that, anything from 5 to, say, 50 kilowatts electrical output is called mini CHP and can service a reasonably sized commercial building, for instance. And above that, we talk about package CHP because it's a sort of turnkey, and it can be easily slotted into a building and whir away at the bottom, and in the bottom of a basement, and be sort of remotely monitored with very little fuss in terms of needing to operate the machine yourselves. As I say, the telemetry means that the thing can be monitored externally. And so that's what's referred to as package CHP or turnkey CHP, and that goes up to, say, 2 megawatts. Beyond that, we're into sort of the world of light industrial, perhaps a large community scheme, and that can go up to, say, 10 megawatts, that's sort of light industrial. Anything beyond that, we're talking about fairly heavy-duty pieces of kit. They tend to be bespoke, so built to purpose, and from 10 megawatts upwards, we're talking about sort of industrial. And when we get above, say, 50 megawatts, we're talking about large-scale industrial or large-scale CHP.
Right.
So it's quite a lot to take in, and there's a degree of subtlety around those definitions.
And many different sizes, obviously, according to the requirements. And it sounds like the domestic market is yet to be tapped. So at the moment, what kinds of facilities are we talking about where CHP units are installed?
Well, typically they've been on the public estate, so they've been whirring away in hospitals and universities. This is sort of package CHP, I guess, up to, say, 2 megawatts. And there's increasingly, with sort of carbon targets and carbon constraints, and the need to reduce the price of energy costs in the public estate to get value for you and I as taxpayers. There's an increasing demand for those sort of products in the public sector. That's also mirrored by the commercial buildings as well. Commercial buildings have a quite an insatiable demand for on-site electricity, heat in the summer months and cooling. Heat in the winter months and cooling in the summer. And
are there any incentives for developers or clients to install CHP units?
There are. There seems to be a bit of a muddle of incentives, really. It would have been good if someone had sort of sat down and thought, well, what does CHP need to make it fly? But I don't think that's what we've got. We've got a sort of a muddle of incentives, really.
Like?
Well, for instance, on the sort of large-scale CHP, anything down to sort of small-scale CHP, package CHP, you get relief from the climate change levy. A climate change tax, which you'd have to pay to the Exchequer, which is levied on your fuel inputs. So you pay it on the gas that you're putting into into a boiler, for instance, and CHP is exempt from that tax, and on your outputs as well. So you've got levy-exempt electricity, which you can offer to your customers.
And do you think those incentives are enough for developers?
I think if we had certainty over the current incentives, then certainly it would be enough. CHP is stagnated in terms of its capacity. It's sort of been around 5 gigawatts for quite a long time.
You're saying if we had certainty, what's the uncertainty?
Well, the uncertainty is around the climate change levy, actually. The climate change levy exemption on your exported electricity only runs until 2013, beyond which the government would have to apply for a further state aid clearance, or we think they might do. and so far they've been unreluctant to do that. But we're hoping very soon that things will change. And in the budget 2009, we're very much hoping for a strongly worded statement that that's their intention to extend that climate change.
And of course, they have released this paper, haven't they? The heat and energy paper. Yeah. What role does CHP play in that, briefly?
Well, it's very encouraging actually that paper, and it was the culmination of a lot of the work that my association or our association's been doing. Typically, government recognise or continue to recognise the benefits of CHP in terms of affordability, reduction in CO2 and other greenhouse gases, and security of supply. As I was talking about earlier, there's a requirement for a primary energy saving when we're talking about cogeneration. So that can mean that fuels go a lot further by saving 10%. Over and above a business as usual case.
And of course they use the phrase good quality capacity, don't they? Well, what exactly is that, and are you on target for that?
Well, good quality capacity is really the UK's quality assurance programme to make sure that CHP lives up to the standards that we've talked about, i.e. the 10% primary energy savings and the 70% overall efficiency, which is required in European law. The UK government, it was the first scheme to do this in Europe, has to have a programme which certifies that CHP meets those standards. And the term good quality CHP is once you've meet those standards, and they're fairly demanding standards. Once you've met those, then you're considered good quality CHP.
It is a bit odd though, isn't it? Because just take one example. I mean, it was back in 2004 now, but 57 CHP schemes, which admittedly have had a megawatt capacity of 28 megawatts, they were mothballed, weren't they? Which sends out a very strange message. Why was this?
Well, I mean, the thing to say about CHP, as with any sort of form of generation, really, it's you only run it when it's economical to do so. And in, say, 2004, we were in a position where gas prices were not particularly reasonably expensive, but the price of electricity was relatively cheap, and that's the real economics that sit behind CHP. It's the cost of gas, so your fuel burn on one axis, and your cost of electricity on another. And the further those two go, it's referred to as a spark spread, or in the case of coal, a dark spread. The further those two go apart, the more attractive it is for you to generate your own electricity on site.
But for any scheme to be shelved, it damages your reputation, doesn't it?
Well, I wouldn't have said it damages it a great deal. I mean, CHP capacity has increased beyond 2004. Sure, those schemes were mothballed, but that could have been due to a number of other reasons. As I say, the economics of running the plant, whether or not that plant was simply simply an older plant and had to close down. Or an important point to make with CHP is that it's very dependent on the heat host that's taking heat from you. So, for instance, in that scheme, or a number of those schemes, the CHP could be situated next to a customer that he's providing heat to. And if that customer decides he no longer wants the heat, or he closes down his operations and moves to India, or wherever else, and not there, then the CHP operator has to run his plant as a gas power station, just electricity generation, rather than a CHP. He loses his good quality status, and therefore he's struck from the database.
In November, the Carbon Trust published its findings from 5 years of field trials on micro-CHP. The results were mixed. For small businesses, micro-CHP was found to reduce CO2 emissions by 15 to 20% and save thousands of pounds due to reductions in demand for grid electricity. For domestic users, the available technology was deemed best suited for larger homes with 3 or more bedrooms, and in older houses where it's costly to improve insulation. However, in smaller properties, the Carbon Trust said micro-CHP offered limited benefits. Deploying devices in the most appropriate applications is the key to maximising benefits. According to the report, the common success factor for both domestic and commercial applications is the matching of thermal output of micro-CHP devices to the buildings where they are used to ensure that they operate for many hours at a time rather than intermittently. The carbon-saving potential of micro-CHP, it added, has therefore found to be best in buildings which require long and consistent heating periods.
So hang on a minute, Peter. Micro-CHP is only any good if you have a huge house and you want it heated throughout the summer.
Well, no, I wouldn't agree with that. I think that there's, I think the first thing to say is that micro CHP technology isn't sort of a monolithic whole. There's various different types of micro CHP technology which are being developed at the moment, and those will have varying heat to power ratios, i.e. the thermal output compared to the electricity output, and those profiles, those heat to power profiles, will suit different properties. For instance, a house which is a fairly leaky Victorian house, say that we might, one perhaps that you might find down the road, say in London, there'd be a great demand for heat within the home, even if you've done all you can in terms of loft insulation, etc. And so a heat-led technology such as perhaps Stirling engine micro CHP might be appropriate. And in a different home, for instance, a newer home, for instance, with perhaps higher energy efficiency standards and insulation standards, a different technology or different micro CHP technology might be suitable, say, for instance, fuel cell technology.
So just briefly then, Peter, what did the CHPA take from the Carbon Trust findings, and have things moved on since that report?
Yeah, well, I think the first thing to say is it was actually incredibly positive that you get an organisation like the Carbon Trust independently verifying the carbon credentials and some of the cost savings that you can make with a micro CHP product. The second thing to say is that I think that there has been a lot of product development since then. It's important to say that when those trials were commissioned, there were only a very few amount of micro CHP units on the market, or not on the market, being developed, and so there was only a very small slither, and since then, as I say, there's been a sort of a product development. Different manufacturers have come into the marketplace with offerings, or are developing these products.
But we are still at the early stages, Peter, aren't we? So, I mean, are you happy that there is enough knowledge within the industry to correctly advise clients on the best size for their needs?
Well, I wouldn't say we're in an early stage. I think that that some micro CHP products are looking at commercialisation, fully commercialised
they're not prevalent,
products.
Are they?
No. Certainly not at the moment. They're not. But I think in the future, given that micro CHP offers sort of an average household or a replacement for his domestic boiler, which can save carbon, can produce a little bit of electricity, and can save them some money on their fuel bills, I think that would be an attractive offering. But in terms of the capacity within the industry to relay to customers or potential customers the benefits of each technology and the subtleties around that, I think that there is a great capacity within the manufacturers to do that. But clearly, when these products become sort of mass market products, similar in scale to the current boiler market, then you might have that's going to strain these manufacturers' capacity. That's why we're seeing quite interesting and exciting developments in terms of tie-ups with larger utilities, who of course have got they've got the route to market, they've got the supply chain, they've got the people that can get the kit into the homes in an appropriate manner.
But if you think about modern boilers, I mean, they're already pretty efficient, aren't they? So how would you persuade somebody that they want to change over to a CHP unit?
Well, sure. I think the first thing to say is that modern boilers are efficient. They're perhaps not as efficient as some of their SEDBUC ratings say they are once they're monitored within in situ trials.
So you would argue that they're better than most modern units?
No. I'm just really making the point that some performance claims aren't they don't live up to that billing. But no, the important point is that if, as I say, if the householder wants a simple replacement to their domestic boiler, which can help combat climate change by reducing CO2, and can save them a little bit of money on their fuel bills, then it's a good option.
Yeah. And would they be worried though that they might be removed from the grid?
Well, no, that would be rather startling.
That was a serious question.
Oh, right, okay. Okay, sorry about that. No, I think there's a misconception that you're sort of cut off once you put a micro CHP product into
and
your...
you're not?
No, I think you'd still have an existing grid connection, so you can, so you'd be able to export, you know, your surplus electricity and import at times when you're not generating enough on your own. I mean, that would mean that your husband could watch the TV while, you know, you...
Well, I'm cooking dinner.
Yeah.
Yeah, I've got your number. No,
Not at
I mean,
all.
it seems that, you know, if this is going to help climate change, this is something we should be looking at very seriously. Is there some legislation that's going to help to push this forward at all, or any kind of directive?
Well, interestingly enough, last year the government passed its Energy Act, Energy Act 2008, and within that there's enabling powers for the government to bring forward a feed-in tariff for micro CHP, and a range of other technologies. There's a bit of jargon, really, feed-in tariff. It really means giving you a payment for the export of your electricity, or your gross production of electricity. So that provides an incentive for householders to get a realistic value or a decent value for their exported electricity, and that should create a bit of a pull. There's also other programmes currently in place. There's a VAT reduction for installation of micro CHP by an accredited installer.
But the trouble is, Peter, surely centralisation of power supply has got to be more efficient than hundreds of little CHP units dotted around our towns and cities. I don't quite get it.
Well, I'm sorry to completely disagree with you, but no, it is. It's decentralised energy, or put simply, moving the point of generation closer to the end user is miles more efficient than centralised generation. Currently, if you have a power plant whirring away, say in a field in Pembrokeshire, your plant will be discarding half of the energy that it consumes in the first place in the form of heat. So that heat's lost and vented to the atmosphere or into a river, for instance. Once you've produced some power, then you've got to take it to that end consumer. And that means passing it down the transmission network, distribution network. Transmission network's pretty efficient, sort of perhaps 5% losses. But once you get down a distribution network, the losses can dramatically increase. And so if you're moving that point of generation, so you can take advantage of the heat that's produced and not waste that, and you can use that electricity closer to the point, or generate that electricity closer to the point where it's going to be used, then it's a lot less wasteful.
But still, if individuals are taking responsibility for their own power and generating their own power, is there the fear that this might lead at some time in the future, the government perhaps thinking, oh, well, we can absolve ourselves our responsibility to ensure continuous power?
No, I wouldn't have thought so. I think the government would have an interest in maintaining the networks that we have in place, and certainly enough capacity to make sure that the lights don't go out anytime soon. I think in the case of CHP, either micro, small scale, or sort of community schemes, they can reinforce the network. So, for instance, when we had the blackouts in New York, for instance, the systems that were CHP, or the buildings that had CHP or backup generation of some kind, were the ones that didn't, the lights didn't go out. So I don't think the government's ever going to forget its commitment to ensure that the lights.
And we
stay
can't find a single reason not to think this is a great thing.
Not particularly. No,
Okay.
not off the top of my head.
Let's take a quick look at the key points that the CHP Association recommend one should consider before purchasing a CHP system. What are your annual heat and power needs? CHP is ideal for buildings requiring heat and power together for more than 4,000 hours a year. What is your electrical load profile? It's more important to understand the base load profile than the mean or peak profiles. Know your heat demand in kilowatts and degrees C. CHP units vary widely according to the amount of heat required and the temperature it is required at. Some engine manufacturers will offer engines with much higher jacket heat recovery temperatures than others. Know how much you currently pay for heat generation. By knowing your current billing figures, you can produce a precise cost comparison, demonstrating the potential savings to be made from each CHP system. If in doubt, go small. A CHP that is too large for the application won't save, whereas a CHP that is too small will, although slightly less than it otherwise would. Understand life cycle cost. The cheapest CHP solution identified during the procurement process will not necessarily be the cheapest to run over a period of time. Track record. There are many existing CHP systems that underperform, so look for a supplier with a good track record. Purchase an operations and maintenance service contract. Buy an operation and maintenance contract at the same time as the installation. This will guarantee the system's performance. And finally, know which renewable grants and funds you can apply for.
Well, Peter, I think you've done a very effective job of convincing us here that CHP is the way to go. So if people want to take it further, the next question they're going to ask is, OK, are there any BRE or BSI guidance that I ought to be looking out for now?
Well, I think the most appropriate place to look for that information would be on the government's new website for information about CHP, which is CHP Focus. The CHP Focus website is a very good website, or come and speak to us if you're interested in getting an idea of the manufacturers and the products and services that the industry we represent. So.
Are you ready for this? You're going to be inundated. Peter, thank you very much indeed. Unfortunately, that's all we've got time for. As always, you can find out more information on CHP in the study notes that accompany the programme. Well, my thanks once again to Peter, and until the next time, goodbye.